So we'll try as much as possible to talk about trig function, parametric equations, implicit rule, logarithmic equations, and hyperbolic probably. Yeah. Although we won't solve a lot of questions, just a few tutorial sheet questions. So we'll start with trig. Suppose you're given f of x equals to. So if you watched my previous video on trig, we did some of these. So I hope you still remember, or maybe you can just go back and have a glimpse. Oh, yeah. So as you can see, this is a product of two functions, meaning we have to use the product rule. So we'll say let u be equals to x squared and v be equals to x. So we differentiate u prime is equals to 2x and v prime is equals to, sorry, we first have to write that again. We write it as, so we form the chain rule from this. So as I said in the chain rule, this drops the power, then differentiate the inside part. If you differentiate sec with respect to x, we get sec 3x done 3x, and then you maintain what's inside, and the power reduces by 1. So that's that. So we have the product rule as v plus u prime. Our v is simply sec squared 3x. Our u prime is 2x. Our u is x squared. Pardon me. So I think we can leave it here. There's nothing much we can do. There's nothing much we can do, so we'll just leave our answer. No, there's something we can do. So sec 3x multiplied by this, well, then 3x. Then we can factor out 2x sec. We have 1 plus. What do we have here of x? Then 3x. So that's our derivative. So in this video, we also talk about parametric equation. For instance, you are told to find the equation of a tangent, and then you're given these two parametric equations. So first things first, you're told to find the tangent at the point where t is equals to 2. So you have to find the coordinates first of all by replacing 2 in this. So the x coordinate can be found by saying 9 minus 2 squared. That's 5. So that's the x coordinate. So y coordinate. So select p be equals to this. So this is our coordinate. And then from here we can say we can differentiate this and this independently, where we say dx dt, the derivative when constant is 0, and then that we simply have 2t. Hope you know how to get that, hopefully. And then there we have 2 plus 6. And then now in order to find dy dx, we'll say dy dx divided by, sorry, in order to find dy dx, we'll say dy dt is divided by dx dt. For any parametric equation we use this, so always remember this. So what is dy dt? Is 2, we'll factorize that, divided by negative 2t. So the 2's cancel, so we have dy dx is equals to negative t minus 3 over 2. The negative multiplies with that. So our t is simply, now we have to find the gradient, since we have already been given the point. And then if you recall, I said something like a derivative is simply a function that gives the slope at a given point. So in this case, our given point is t equals to 2, and then we have the derivative. So in order to find the gradient of the tangent, we simply replace t with our given value. So our gradient is that. So we'll go back to coordinate geometry. I hope you remember this equation. Our y1, we had 16, the gradient x1, what's our x1? Our x1 we have 5. Yeah, y minus 16 equals negative 5 over 2x plus 25 over 2. I say y negative 5 over 2x plus 25 over 2 plus 16, multiply everything by 2. So this is simply the equation of the tangent. You can leave it in that form, or you can make y the subject. So I think for this video we'll end here, and then we'll talk about implicity and logarithmic functions in another video, just to make it shorter.